Hello, everyone, and welcome to this next session with the wonderful Dirk Songuer. And I hope I'm saying that right. Correct me if I'm not. And we're going to be talking today a bit about approaching the metaverse for businesses and brands. So I'm really excited to pass the reins straight to Dirk. My sincere apologies for the delay in this session. It's all on me. I was sitting listening with real interest to another talk and just completely got lost. But my bad. So really excited for this, Dirk. Reins over to you.
I mean, Miles, who can blame you? I really enjoyed the talk so far and the panels and everything. So hi, everybody. My name is Dirk. I appreciate your time. So sorry for being a bit late. So this is going to be a pretty dense talk. So I apologize if things move a bit quickly to make up time. Feel free to reach out. I'll make sure to answer all the questions. I'll hang out in the meeting area afterwards. If all else fails, grab me via LinkedIn or Twitter. Okay, let's go. So this is what I do, or at least how we like to show it. I work for Microsoft on the strategic development and acceleration of the metaverse, specifically working around the Internet of Things and mixed reality. And to make this clear from the start, I want to have some fun with this talk. So while I work for Microsoft, ideas and opinions in this talk are my own, and I do not speak for the company. But I have been in the space for around 11-ish years, working on brand and experience side of things, for example, AAA games, and then digital retail, theme parks, hotels, casinos, city-scale digital infrastructures. And I also worked on enterprise and industry side of things in mobility, manufacturing, logistics, and fashion. And the best way to describe my work is that I help clients explore potential futures, understand the impact, identify desirable futures, and then make those actionable with, for example, roadmaps, milestones, clear next steps, those kind of things. Today, I want to talk about two things that will explore different ways to approaching the metaverse. First, why the metaverse as a concept is confusing and why defining it is even more confusing. And then I want to get into the nitty-gritty and look at some ways to get from confusion to opportunity. Let's start by outlining what the metaverse is, according to the news you've probably read this morning. So the metaverse is 3D avatars, immersive meetings, collectibles, games, content creation, entertainment, and all of that is true. Well, that doesn't really capture the possibilities and overall spirit of it. It just talks about specific aspects and technologies. And then you look at the next 10 articles where NFTs are scams, crypto is pretty much a Ponzi, and by the way, Facebook's metaverse is looking like a dystopia. And that's also kind of true in many ways, but it's still not really helpful. It's just the flip side, turning hype into hysteria. And the next articles mention studies and reports, and they all go a little bit like this, where this is where it really starts, and in 3 years, you will be making loads of money. Which is funny if you read 3-year-old reports that claim you should be making billions right now. So none of this is really helping. The way metaverse is currently used by the media, by analysts, and sadly by us in the industry is not really helping to provide clarity on what the metaverse even is, what will it enable, and what specific opportunities are. And we're cherry picking to shout either overly positive projections or horrible hysteria into the void. And while all might have a grain of truth, it does not reflect what's going on in the space. So what is the metaverse then? Well, truth is, although the metaverse has become a hype now, it's been around for a very long time. Only previously, we mostly talked about social virtual worlds. Fundamentally, social virtual worlds are all systems where people act within a platform, spatially or contextually, interacting with the platform and with each other. You do all these, congratulations, you run a virtual world. And this covers platforms from multi-user dungeons, which are essentially text-based MMOs, to 3D MMOs like World of Warcraft, to multi-user shooters and experiences like Fortnite, but also sandboxes and collaborative spaces like Minecraft. And in 2006, a lot of smart people got invited to an exercise in the Institute for the Future to explore paths into 3D metaverses. Essentially, they wanted to know what happens when virtual worlds meet real maps, and what happens when simulations get real and life and business go virtual. And this is the model they came up with. Again, 2006. They looked at what was back then virtual worlds and divided them into 4 quadrants based on world-focused versus identity-focused and real world versus constructed worlds. So virtual worlds are platforms where virtual identities explore virtual maps. A virtual character running around in a virtual meeting room, or Azeroth in World of Warcraft, or a map in Fortnite or Minecraft. You know, the examples I've just given. But if you swap out the virtual map of the world with a map of the real world, well, then you get mirror worlds, where an abstraction of you travels the real world. You can explore parts of the world you're not currently present. For example, an avatar of you running around in a real map of New York, for example, Google Earth or Google Street View. But also all other forms of abstracted maps in the real world that you can act on with an avatar of yourself. For example, a dot representing you moving in Google Maps or your Uber. Technically and conceptually, both are pretty much the same thing. In one case, you move around a fictional map, and in the other, a real map. You can also get rid of the map entirely and project everything onto reality directly. And of course, in this scenario, you act as yourself, as the real person moving around in reality. And again, this is the same thing. You just switch the map data, or rather you scaled the real world map data to 1-to-1 size. And if you were in the Building the Metaverse panel earlier, Sarajini from Alien Worlds and Harish from Superworld, they talked about their projects being like Pokemon Go plus Foursquare plus social networking. Which brings me to the last quadrant. You can also augment the representation of the individual, not just the map. So in 2006, live logging became a thing, and today we know people augmenting themselves into characters as social media influencers. Technically and conceptually, again, they're the same thing. You just moved from augmenting the world to augmenting the image of a real person. And we can look at the requirements for such metaverses and eventually end up with the requirements for social virtual worlds. You do all that, congratulations, you're in a metaverse. You can think of these as contextual, transparent, multi-user systems. So yes, these attributes describe Minecraft and Google Maps and Pokemon Go and Facebook and pull them all conceptually into the metaverse. Really, the only difference between Minecraft and Google Street View is that one map is based on a fictional world and the other on a real one. The only difference between Uber and Pokemon Go is pretty much what they spawn on their maps. And Twitter is pretty much any massive multiplayer game, but they only bothered to develop the chat part. The metaverse really is all of this and more, spanning from people to things, to environments, to worlds, regardless of being fully virtual, digital physical, or fully physical. Another way to look at a metaverse is to actually, well, look at it. A future vision is something that hasn't existed as a real product. However, concepts or principles are known and understood and accepted on a society level. Pop culture artifacts like books, movies, TV series, and so on are usually a large driver of those kind of visions. And they will inevitably inspire and influence public expectations, and thus investors, and thus you as creators, and thus the end product. So to understand a metaverse further, it's interesting to look at these visions. And these are just 3 examples of future visions around the metaverse. You can find a lot of them on YouTube, but they're surprisingly similar. If you look at these videos, you can think about what kinds of technologies do they show? In what quadrant would you see these scenarios? And looking at these visions, most of them show a world where digital augmentation reaches into the physical world, where all 4 quadrants are used, sometimes jumping from one to another. And that makes sense, since no trend and no vision, and indeed none of these metaverse quadrants can exist in isolation. Pop culture is influenced by technology and also influences technology. One way to look at this is to imagine that technology, society, and our environments behave a little like pressure, temperature, and volume in a gas. If you change one of them, the others have to change too. For example, if you go to the moon, and I mean literally, the environment will be very different, and you need new technologies, but also likely new forms of society if you want to stay there. If new technologies come along, like in the Industrial Revolution, societies will change, but also it has an effect on our environments, for example, city planning and mobility. And finally, looking at different countries, societies do behave differently and have different values, and thus making decisions which technologies they embrace and how to shape their environments. This is also why visions like Ready Player One won't happen, because the metaverse won't be isolated within just one paradigm or quadrant. It doesn't make sense to have this advanced technology in one aspect of your life and not in any other. It's a nice approach to fiction as a narrative device. It's just not a realistic one. That picture would be like smartphones evolving to exactly like the iPhone 12, but you can only use it when you're sitting at home. And the most popular game is to see who can sit down the fastest and then they get a virtual car or something. It doesn't make sense. Progress in one aspect of the metaverse will also affect and enable all the other aspects. And these visions show progress across all 4 quadrants of the metaverse roadmap. Looking at them, you can ask questions like, how do people interact with technology in these visions? What kinds of societies do these people exist in? What does it mean for the environments they lived in? And looking at the visions again, they also create other kinds of interesting questions. Mostly, where does this data actually come from? How is it collected? And if this data represents the state of the real world, what will happen if you change a value? Does that change the virtual world propagate into the real world? What will happen if you change data representing other people? And those kind of questions are usually associated with a paradigm of ambient computing, meaning digitalization of physical space. Remember when I talked in the beginning about digital experiences, retail, hotels, casinos, industries, that kind of thing. And all of that is being subsumed by the metaverse right now. That makes it even more complicated, and I'm sorry. At this point, the best definition seems to include 2 huge megatrends, each with dozens of large subtrends and even more moving parts. So how can this lead to a coherent system? And the answer is it probably won't. And that's fine. After all, GeoCities was the first big glimpse of the web, and it was kind of messy, but also really awesome. It was the entry for a lot of people, and it allowed everybody to have their first voice on the web, to be creative and have fun, and it paved the way for the web we know. The point is, the first step in understanding the true potential of the metaverse is probably to give up on trying to artificially create a moat around your specific precious definition of the metaverse and allow some chaos and blinking text. It won't just be one thing or the other, VR or AR, headsets or phones, real or virtual, trustless or lawyers. The answer will be yes. It's confusing, but also diverse and fun and full of opportunity. So, as I said, the attempt at defining the metaverse might be confusing, but there are always ways to approach it and get from confusion to opportunity. One way to approach the opportunities of the metaverse is to look at the individual components. Because if the whole thing is too big and messy, we can probably dissect it into social and technological components and look at them individually. And for example, by looking at specific subtrends to see how they affect, interact, and enable social virtual worlds, and thus the metaverse and how it will make them scale. And a way to approach those individual components is to ask why they exist in the first place. Are they driven by society, by environments, or by other technologies? How mature are they, and what will accelerate them? And all these questions will act as a kind of lens through which we can view the world and then make assumptions and predictions around scenarios and opportunities. And I want to make clear, these are really assumptions and predictions. There are many models and frameworks representing different lenses through which to explore potential futures. Some others I really enjoyed seeing during this conference. Right now, let's look at the interplay of trends with social virtual worlds based on the metaverse roadmap. Let's start with a foundational technology, the Internet of Things, aka where do we get all this data from? The driver for IoT is pretty simple economics. It's cheaper. To explain that, I usually ask a very simple question. Please go online and find the cheapest printer you can buy. I would make a poll out of this, but let's continue. Chances are you will come up with something like this, right? It has a color touchscreen. It's Wi-Fi enabled. It can not only print, but also scan and fax. It has apps. So how come this is so cheap? In fact, cheaper than a printer that can just print and does not have all those shiny features. The reason is this printer is essentially a smartphone. At least from the components in the printer, they're the same as a smartphone. See, you have the rule of scale in production, which means the more you produce of something, the cheaper it gets. And since smartphones are produced to scale, the components are very, very cheap to buy. Cheaper, in fact, than creating custom printer components developed from scratch. But as smartphone components also come with capabilities like connecting to the network, touch input, image recording, all of those capabilities you will also get for free. And this is true for pretty much everything with some kind of electronics inside: fridges, toothbrushes, cars. It doesn't really matter what it is. Scale components are cheaper than bespoke ones. And yeah, there will always be a professional and luxury segment doing their own thing, creating their own chips and components, but scale technology will bow to price, especially these days when production and supply chain is difficult. You cannot escape this rule of scale. At some point, certain components will be so cheap that you'll just use them for everything in your bag: watches, cameras. At this point, you could argue that nobody needs a smart fridge, a smart toilet, or a smart toothbrush, and certainly no smart hairbrush and other small insignificant little things. But this discussion is pointless. Smartphone will set the pace, mundane things will follow, because that's the cheapest and easiest way to design and produce products. The Internet of Things adds digital capabilities and ultimately behaviors to physical things. This will include everything that can, in any way, shape, or form, be digitized. If it has electrical components, it will eventually be a connected device. However, new opportunities will emerge if everything that can be digital is digital and collecting data. You remember the headlines that data is the new oil? Well, that kind of happened, but very selectively. People noticed that while having data is good, understanding data is better, and utilizing data is best. So the whole notion of big data as just collecting as much data as possible has turned into searching for data services and utilizing them to do more. So institutions just gave their data away for others to do things with. And this example is the data API from Schiphol, Amsterdam Airport, that you can use to build on top of, which is a win-win for both sides. But that meant they essentially created a mirror world. And the handbag full of digitally enhanced things, if we assume they all sense the environment and collect data, it makes sense that they offer some kind of service API as well. And in a way, this turns all devices into little data service websites, like the GeoCities of things, like the crappy smartphone app you get with your cheap e-toy. A wild collection of messy, unorganized, unstructured data pools, not really user-friendly, but interesting. And this is not just true for things, but also environments. This is a project by the MIT Sensible Lab. They added a number of sensors to public city vehicles, garbage trucks, and collected a number of environmental data, pretty much like the Google cars do, only cheaper and different data. And as this continues, we get more and more Google Maps type location-based data. However, instead of streets, they show current temperature or loudness, air quality, particles, creating all these values for different mirror worlds. And the idea is really people and companies will pick up on the individual specialized data sets and create value out of them. Combine them, put them into bigger contexts, create new kinds of services and value chains, and create new mirror world experiences. But this is not just interesting for thing companies leveraging thing data. One or two companies will emerge as an infrastructure for those thing data companies. Because if you have all those semi-structured data pools randomly distributed, then it makes sense that somebody goes and makes it usable. Just like Google emerged from the early internet catalog and made the web searchable and accessible, somebody will make things and environmental data searchable and accessible. And this also requires turning foundational technologies like blockchain into much more approachable platforms, getting rid of current limitations and issues, most likely evolving them into not technically blockchain anymore, but similar in spirit and more practical. There's an opportunity to map the space of mirror worlds and emerge as the dominant search engine and enabler in this quadrant. Next up, cognitive services, or really applied machine learning. These services range from voice recognition and speech analysis, language understanding, that kind of thing, and we need them to fix the complexity issue. As things get more and more digital, they get more and more complex as well. If we look at the state of home automation, we replace our simple analog switch with a digital button to control our digital light bulb. But then we replace the digital button with lots of buttons because digital light bulbs can do much more than just turn on and off. And since we didn't have more room, we replaced lots of buttons with a glass surface to display even more buttons. And that doesn't make sense. So now we replace lots of buttons plus glass with digital assistants to make them simple again. Because look at it, who wants to use an interface like that? It's nice that the light switch evolved into something smart with smartphone-like capabilities over time, but it's just not practical. We need to keep things simple to get back to a single button that essentially does whatever. Like your own personal assistant that you use for mostly digital things or things that can be done digitally. Only you won't talk to a person, but to whatever digitally enabled device and system will be around you, your phone, your Echo, your fridge, your toothbrush, and then they do it. And this applies to virtual spaces too. Just a couple of weeks ago, when item collection in Minecraft became tedious, the community asked for what is essentially a digital assistant to help them pick stuff up, as well as influencing the physical environment. Do you actually think autonomous cars will be the only things that move around? Everything that can move will be autonomous because everything will be digital as well. Cognitive services will support people to be able to interact with things in a natural way as scenarios get too complex to understand. The implication is that it doesn't really matter in which quadrant individual participants live. And with that, I mean, we won't be able to differentiate between a concierge and a digital assistant, or between a human front desk worker and a bot, or a dog or a fridge. You remember this example by Google a couple of years ago? It was an example of Google Assistant calling a human in a hair salon to negotiate an appointment. And that's all well and good until you realize at this point, humans are just expensive bot conversation endpoints. And as bots will be able to converse with humans, the expensive, inefficient element becomes the human itself. And you immediately created another opportunity to optimize, which is strip that away and you're left with just digital agents having conversations with each other, managing, planning, organizing. Things become another augmentation of their users. And as they learn to achieve goals more and more gracefully, they will also use different platforms and communication channels to get there. So this begs the question, what will be the future platform to not only allow humans to interact, but also facilitate human-machine and machine-to-machine communication? Ideally, seamless, and neither party cares nor notices how artificial the other endpoint is. What we now maybe call smart contracts will only be a smart part of this, as we need to jump out and connect all quadrants seamlessly. In other words, what's the Facebook of things? How do you think augmented users will be supported in reaching their goals? And if you have that answer, you can pretty much own this quadrant. If the above assumptions are true, we require a digital and physical infrastructure beyond the current concepts. Before, we had economics and usability as drivers, and computational graphs are really a contextual necessity for all of the above. The best way to explain this one is that it requires context to turn the Internet of Things into the Internet of my things. We really talk about an augmentation of me. A system needs to know who I am and what context I'm in. In other words, my milk, my images, my content. Only then can things and places really react to me, be it proactive or reactive. And graphs allow to generate personalized scenarios based on context. And this applies to virtual, physical, and mixed environments. Here's a recent example by Mercedes-Benz. It's people getting into their car. As soon as the car knows who they are, it would personalize itself based on the driver and passengers. Good. But beyond that, how about the car knows how you slept by getting data from your health and fitness app? Recognizing that you don't feel well. Recognizing that you have an important meeting coming up. And could and should all that maybe influence the seat setting and the temperature and the ride softness? And strange things are happening when digitally enhanced objects interact with us in a direct, embedded, relatable way. Here are two examples, one very low-tech and one rather high-tech. By displaying some form of personalities, these things become relatable. They develop character. And we as humans are wired to anthropomorphize vaguely intelligent entities, especially if we don't understand them fully. We do it with living things like pets, but also inanimate objects like dolls or cars. We give them names, we plead with them if they don't work and don't start, and sometimes form these weird rituals around them where I need to throw up my keys to make my car start. So what would happen if the objects could actually sense their environment, are aware of context, and are able to understand and engage and interact with people? Well, we know what will happen because we have seen this, for example, with Jibo. Marketed as a social home robot, it was designed to use relationship as the interface, and people started throwing birthday parties for it. They took it on their vacations, they brought it to their graduation. In other words, if your interface is a personality, then the user experience is a relationship. For brands, this means something very powerful. You can now shape the experience you want people to have with your products. Going back to the Mercedes example, what do you think the personality of these two car models should be? They do not look the same. They certainly do not drive the same. So why should they have the same personalities? In the real world, why should the driver assistant and autonomous systems drive the same? And in virtual worlds, why should the digital representation behave the same? We will project certain expectations based on the embodiment and brand. So these things will need to emulate behavior according to user expectations as well as capabilities and brand values, something that Sebastien from the Sandbox talked about in the panel earlier. This is what I call relationship design. These parameters have to be carefully designed to not alienate users as well as to promote and foster actual relationship. In this case, alienate means that the object behaves differently than expected. Also training things around brand values and identity. That goes for the personality and tonality of the object, as well as the behavior, regardless in which quadrant. You will not be able to sensibly separate physical product design, digital product design, product support, branding, and marketing in this scenario. Relationships matter regardless if they live in the physical space or in the digital space. This type of relationship design is currently bleeding into the AR quadrant and will likely be a new type of digital capability. Very likely this will spawn new types of consultancies and agencies, and these teams would help design the dynamics between user and object, between brand and consumer, between buyer and product, and empower objects, real or virtual, with personality to make technology more personal and magical for people, essentially shaping relationship between people and environments. But there's a problem. Well, many problems actually. But one of the problems is that dynamic changing environments where you don't understand the rules and cannot control what's happening are a really bad idea. Like if you remember the grand staircase in Harry Potter, it would change all the time, even if people went up or down. It's a labyrinth as a utility, which is a great plot device, but really sucks in reality. But this is what mixed reality is all about. If digital dimensions become so complex and able to influence the real, then we need a way to know what is going on. The more immersive, the better. Usually with mixed reality, you see pictures like this. They usually showcase the ability to see volumetric or holographic or 3D representations of things. And while that's very powerful in itself, the real fun starts if we add the abilities of the other quadrants. And as everything becomes digital, with digital abilities sending data to create those mirror worlds, we create those digital ghost dimensions. They're there, but invisible and unsensible for our normal senses. They're kind of like abstract. So we're searching for ways how to make it sensible, giving us superpowers to look and interact with these digital dimensions. In this example, we can visualize Wi-Fi connectivity as digital overlay, and the warmer the color, the better reception you will have. As technology evolves, future experiences will be able to cover the entire spectrum of mixed reality, from augmented to virtual and everything in between. It's just a question of context. A relationship spans all quadrants anyway. So at this moment, for this task, what is the best quadrant to transport a specific experience? And maybe it's an experience that starts within one quadrant and moves between them as the use case unfolds. As our data moves seamlessly between the metaverse quadrants, we need an immersive way to understand them, to look into and interact within these digital twin dimensions. And this is really the experience aspect of things. So yes, finally, we got to the headsets and VR and AR and 3D and game-like technologies and all that. But as you see, they're only the tip of the iceberg. The method by which we fully utilize the underlying infrastructure. And I could go on, but I'm kind of out of time and we started late. So to sum it all up, we can look at the metaverse as a combination of ambient computing and social virtual worlds. We can segment the metaverse landscape into 4 quadrants based on world focus, identity focus, and real world versus constructed worlds. We can map ambient computing against metaverse quadrants to identify what needs to happen to fully utilize the potential. And now we have a look at experiences, solutions, and platforms and assess the maturity and trajectory of those. But the thing I want to remember is that fundamentally all these quadrants are the metaverse. They are the same from a conceptual and technical point of view. The reason why social virtual worlds and a metaverse can be defined so broadly is that they follow the same rules for social dynamics. The people using them are the same, and they use them the same way. People don't really care if the world they interact with is fully virtual, digital, physical, or fully physical. The effects on their body chemistry doesn't care. That means that the methods and mechanics to design these spaces is largely the same, or at least transferable between all four quadrants. As virtual space crashes into real space, people will try and game reality for fun and profit. Russian bots on Twitter, abusing Facebook algorithms for reach and manipulating opinions. Yeah, I mean, gamers in online games have been doing that for a very long time. And game designers have predicted this behavior in social worlds long before Cambridge Analytica and the 2016 election. The Metaverse roadmap even predicted the model. I mean, play to earn is nothing new. We just called it having a job. There's no difference between the interface is more colorful than Outlook. And it doesn't matter if you built a penis out of dirt in Minecraft, or making videos of penis-shaped clouds for YouTube, or write 4 pages of penis fan fiction on Facebook, or people plotting penis routes on Google Maps. It's all the same. If you have users interact with each other, you will have abusers. It doesn't matter how many degrees you abstract a virtual representation. And if you attach value to that representation or any other form of incentive, the abuse matters, and people will do it not only for fun, but also scale and monetize it. Ad click farms on Facebook are the same as comment bots on Amazon. They are the same as gold farming bots in MMOs. They are the same as people leveling your virtual pets for you. There are ways to automate the value generation on the respective social virtual worlds. Because remember this? Repeat after me. Systems that influence the physical world also influence society. You either do it on purpose or you will do it by accident. All of you. In a random, unconscious way that also leaves room of malicious actors. So better do it on purpose. Because, for example, I'm sure that Pokemon Go didn't mean to be racist and classist, but it was, basing the initial locations of spawns on maps that favored white, rich neighborhoods. And I mean, look at these pictures. You see the metaverse? I see somebody really thought it was a good idea to community manage downtown San Francisco during a pandemic. And yes, Niantic fixed a lot of it, and they did great work. But this shouldn't have happened in the first place. This explains negative sides of the metaverse. This is how you get influencers scamming their communities. This is how you get trustless technology used by people that shouldn't be trusted. This is why it's a bad idea to make the users the product, because it's a great way to incentivize people making money by objectifying other people. People will weaponize the metaverse for fun, but mostly for profit, if you give them the opportunity. The actual hard part of the metaverse is a governance one. In other words, social problems are currently much harder to state and solve than technical aspects. Besides manipulation, it raises questions around accessibility, when digital channels that can manipulate the physical world are only usable by specific groups. If we want to change the dynamics between platforms, producers, and consumers, and we do, we need to think about governance of the space. This is not only a technical problem, it's a social and systems one. So, I hope this was a helpful model how to approach the metaverse, a relatable model to think about big potential opportunities, and I hope I scared you just enough to make you stop and think if you really want to be the one owning a quadrant. Because very likely you will end up with responsibilities very similar to a government, and almost certainly you will be regulated by one. And as we build the metaverse, you might not care about every aspect. You might not even agree or like every aspect. You might be critical of some and hype for others. That's fine. As long as you realize that your specific technology and aspect does not live in isolation, we can do this together. The thing you work on will be just one aspect, one enabler, one word in an entire verse. And that's diversity and inclusiveness. Because who are we actually building all this stuff for? I hope we do it for everybody, enabling every person, thing, and space around the planet to enter a metaverse. so they can leave their mark and adding their voice and bringing their best selves. And yes, hopefully they will also bring chrome horses and raccoon animations and blinking text, memes, JPEGs, all the bad lyrics and fan fiction. Because I think that another GeoCities moment enabling everybody would be pretty awesome. Thank you and take care.